Hey chemists, a little bit of stoichiometry today with limiting reactants, an extra fun twist on regular stoichiometry. Let's take a look back at this classic. Of course, this reaction tells us 2 graham crackers plus 1 marshmallow and 3 chocolate squares yield 1 s'more. The question is how many s'mores we could make if we have 24 graham crackers, 18 marshmallows, and 30 chocolate squares. Well, that doesn't seem like it's going to add up to an even or equal number of s'mores. So let's take a look here. 24 graham crackers, that'll give us 12 s'mores. 18 marshmallows, that's enough for 18 s'mores. And 30 chocolate squares, 3 per, because really that's the best ratio, let's not argue, is 10 s'mores. And so we're going to run out of chocolate after just 10 s'mores. So we can't make the 12 or 18, even though we have enough graham crackers. So when a question asks us, what is the limiting reactant? What reactant limits how many s'mores we can make? In this case, it's chocolate squares. That's the thing we're going to run out of first. So just like with s'mores, let's take a look at this with regular chemicals. How much lead-2 iodide is produced when 1 gram of Ki is added to 0.750 grams of lead-2 nitrate? Well, all we have to do here really is just solve both stoichiometry problems. We're given 2 amounts, and so we've got to do stoichiometry with both of those amounts. So let's dig in. We'll start with our 1 gram of Ki. Convert to moles. 1 mole. And then we're going to PbI2. So let's just head straight there for the heart of the problem. 2 moles of Ki. Remember, these numbers come from the balanced equation. 1 mole of PbI2. You can stop there, but sometimes it's easier just to plow ahead while you're at it. So 461 grams of PbI2 makes 1 mole of PbI2. We can cancel. We're left with grams of PbI2, which is what the question's asking for. I get 1.39 grams of PbI2. All right, well, that's how much we could make if all the Ki gets used up. But we're not sure if we'll use it all or if we'll run out of the other stuff. So let's see, 0.750 grams of lead-2 nitrate. All right, that one has a much larger molar mass, 331.22 grams. Oh my goodness, this stylus, sorry. Okay, in this case, it's a 1-to-1 ratio. 1 mole PbNO3 for every 1 mole of PbI2, which makes sense. And then same molar mass, 461 grams PbI2, 1 mole. We can cancel. And this time I get 1.04 grams of PbI2. So we are going to run out of PbNO3. This is the one that makes the smaller amount. So this is the limiting reactant, and this is our final answer. Always take your final answer from the limiting reactant, just like we did with the s'mores, because we're going to run out of that. We cannot make any more. All right, if you didn't already, pause, check, make sure that you are getting the same calculation numbers that I am. And then let's move on to this problem. Here we want to know how much of the excess reactant is left over. Well, we need to figure out how much of that excess reactant got used up. We had a gram of Ki, but we know we didn't use all of that. So let's work backwards from the amount that we know did get used up, 0.750 grams PbNO3. And really, you could work backwards from anything. You could work backwards from the 1.04 grams of this also and find out how much Ki got used up. Any of them will work. This is just the one I picked for now because, I don't know, I guess I really like writing nitrates in parentheses all the time. 331.22 grams per mole. All right. And then 1 mole PbNO3. This time we're figuring out how many moles of Ki actually get used up. And we'll convert that back to grams. And whoops, not times, equals. I get 0.752 grams of Ki used. That's how much actually react. Well, if we had 1 gram and we used 0.752 grams, we can just subtract and find that 0.248 grams of Ki are left over. That's what the question is asking. So you can always work backwards and use any combination of things that you've already determined to figure out that last bit of stoichiometry. Let me know if you have questions about this. Please do practice these calculations yourself. Talk to you soon, chemists.